Hey there, and welcome back to the channel. In today's video, we're going to be learning everything about breadboards and constructing circuits. Now, if you haven't seen the prior video on circuits in this series, follow the link in the description below, watch that video, maybe give it a like, and then come straight back here. The concepts in that video will make everything more palatable in today's video. So without further ado, let's get into the fun stuff. So where did we leave off last time? Well, we discussed the three essential components of a circuit. You might recall that's the source of power, conductive paths as you see denoted here, and the load of the circuit, which, just to recap, is essentially a component that uses power from the source in order to operate, like an LED or a motor. But that may have left you with some questions, like what do I do now? How do I actually assemble a circuit? And what does a circuit even look like? Now, the short answer to all these questions is that circuits are built on breadboards. Well, at least they are when you're just starting out. Later, when you become more advanced, you're going to actually start working with PCBs to build your circuits, but we'll save that for another video. First, we got to get through the basics. So let's start out by talking about what's a breadboard. Well, a breadboard, put simply, is a construction of these conductive paths that we mentioned is one of the three essential components in a circuit. So again, we have the source of power, which uses conductive paths to go to a load. Conductive paths. What the breadboard is, it's an assembly, it's a construction, a logical organization of conductive paths that make it easier to go from your source to your load. Examining this image here, which is an image of a traditional breadboard, let's write this down, traditional breadboard, you should notice all these holes, right? You should notice they're labeled A, B, C, D, E, and you should notice these two positive and negative layers of holes, and then we have, of course, the same thing here. Now, it might not be obviously apparent what these holes are for just yet, but when we examine the schematic here on the right, it should become more clear. Let's start with the sides and work our way inwards. Here on the sides, right here and right here, here and here, we have what are called power rails. As the name suggests, they are where the power source is usually incorporated into the circuit. So you notice that these circles represent the holes in the previous image, okay? And you'll also notice that they're connected. Why are they connected? Well, that means that they're actually connected via a metal wire. So in reality, what a breadboard is, it's just metal strips going along inside of an enclosure. And now the enclosure has these holes that enable you to connect items like power sources there to actually operate your circuit. So what does this actually look like in circuits? Well, it enables you to connect a power source to the very end here and attach various wires, like say here, 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 for example, that will bring to a load in a circuit. So let's imagine these are all going to separate loads in the circuit. It's all coming from the power here of a battery that, say, is attached. Looking inward now, we see that the holes are connected perpendicularly to the power rails. So we have them connected like this, whereas the power rails are connected horizontally. Now, why is this advantageous? Well, say you bring a wire from here, like I drew earlier, to right here, and then you want to attach a load somewhere here. Let's say it's an LED. Well, one leg of the LED will be here, and the other leg of the LED will be here, so it'll be mounted like this. That means that the current, let me draw this out in yellow, that means that the current will flow from here, through here, and back to the negative terminal of the battery. So as you can imagine, this is going to be pretty helpful when working with circuits, at least when prototyping in the initial stages. All you need to do is know how these wires are assembled, and you'll be able to connect components via these provided conductive paths. Alright, so now that you're relatively familiar with how components in circuits are theoretically connected, you may or may not start to be understanding why this way of prototyping is so widely used, why it's so popular. Well, primarily it's the fact that a breadboard allows you to prototype electronics without the need for soldering. Now, without getting into too much detail, soldering is a process where the components of a circuit are joined together using a metal filler, like you see here. That'll be melted, and then it'll be used to connect two components. We'll also get into this later, but the point is, without the proper tools, prototyping and soldering would be impossible, especially if you're a beginner. And the great thing about breadboards is that you just need your components and a couple of wires. If you don't get it just yet, not to worry. We're going to construct an actual circuit right now. Alright, so now we want to actually make sure that you're understanding everything that was just shown in that previous clip. So let's start out by talking about this image right here. So I want to talk about the flow of current from the source of battery and back to the source of power, which is the battery. So as you can see here, it follows this red line to this yellow line, simply passing through this on-off switch. So we know for starters that the power is right here. That's where it's coming in. Now we also know, let's use a different color here. We also know that there's things called power rails that run like so and like so. So what does this mean? Well, it means that the power is getting inputted from here. It'll connect with this wire that's connected right there. Now from there, the power will flow through this wire and actually land right here. Now since these ones are connected I guess semi-horizontally in this case, I guess if we call these vertical, these will be horizontal. They're connected like so, and so it'll flow from the edge of the wire to the LED, and from there it'll flow up the LED, do its thing up here, and flow back down. Now it's back on the breadboard, the power, and it'll flow to this resistor here, and then it'll get obviously to the end of this resistor, which by the way just limits the amount of current that can actually run through the circuit so that it doesn't blow up under any circumstances. And then finally it'll come through here and take this wire back to the ground terminal. So as we said, this is a power rail, so it'll flow from this point here back to the negative terminal of the battery. If we look at this from another angle, you can probably see this better. So of course we have, let's switch up the colors here. Of course we have the power going from here to here, then from here to the LED, and finally from the LED to the resistor, and then it'll flow through the resistor and go from the resistor back to the negative terminal of the battery. So if we take a big picture look at how this is done, it's going from the positive terminal of the battery through to the load. This is our load of the circuit, and back to the negative terminal of the battery using these conductive wires here and here. Alright, just like that, the video is over. If you found this video helpful or enjoyed it in any way, be sure to like this video and subscribe to the channel for more videos like this to come. See you next time.